right, in chapter 17.8, we're going to discuss the concept of protecting groups. What we have seen is that for a number of different kinds of reactivity, there are severe limitations on what can happen. And that's the case for Grignard reagents. They're very basic. And so, for instance, if you wanted to try and make a Grignard reagent from this bromide, if we were to react it with magnesium to make that Grignard reagent, often you will see written from students' work, it's magnesium bromide. But what's the problem? Right, we just covered Grignards. This is, of course, a very basic bond. In fact, we can think of it as minus on the carbon and plus on the magnesium. And that's a good way to conceptualize it. And so this alcohol proton is very acidic, and so they will react, and you in fact don't get that at all. What you produce is you put a hydrogen there. So we need to be able to reduce the reactivity or remove the reactivity of that proton, and we're going to do that using protecting groups. So the first protecting group we're going to learn about in the general form of the reaction is the silyl ether. Now, ethers are stable to basic conditions. Okay, that should be a minus because we remove that proton. In this silyl ether, the general reaction is that we take an alcohol. We can react that with trimethyl silyl chloride. This is done in the presence typically of a tertiary amine base, like triethylamine. And we convert the alcohol to the trimethyl silyl ether. Now, if we block the reactivity of that hydrogen by making it into an ether, then we have to be able to unblock it, get it back, and that is we have to deprotect. So this is the protecting group synthesis, and then we need deprotection. In deprotection, all right, coming back to this now, deprotection. So we made the silyl ether, we can do the reactivity that we want, then we have to do a deprotection step. So this adds two steps. So the deprotection step is the trimethyl silyl ethers, which are stable to base, are highly susceptible to acid and aqueous conditions. They will rapidly hydrolyze and return to the alcohol. So this is the new chemistry that we need to understand, but it's really the application of that chemistry that's really critical here. So let's go back to the Grignard that we had a moment ago. If we want to make the Grignard of this compound, what we have to do first is put in the protection step. So trimethyl silyl chloride, trade out pens here. And triethylamine puts a TMS group on the oxygen. So we have now protected the alcohol. It's a silyl ether. It's no longer an acidic proton. We can now react with magnesium metal. This will produce the magnesium bromide compound. The magnesium inserts into the carbon-bromine bond. This is now our Grignard reagent. The alcohol is protected. There's no problem of reactivity. We can now react that with an electrophile, say benzaldehyde. This does the standard addition of a Grignard reagent. This will produce trimethylsilyl ether. So 1, 2, 3, 4 carbons. Make sure you track with me. 3, 4. 1, 2, 3, 4. Now we have the new bond to the aldehyde, and it is an alcohol after we do the workup. So workup is assumed. If you need a proton or something, that's just an assumed part of organic chemistry. So to get to the diol, for instance, that we might want in pharmaceutical synthesis, the only thing we have left to do is to deprotect. So catalytic acid is more than sufficient, and water, and we can get back to the alcohol. So whereas we couldn't do the direct addition of the Grignard with the alcohol present, when we go through a protection step, and then we need at the end the deprotection step. We need 2 more steps, but we can get to the product, whereas in the first example, if we tried to make this Grignard and react it with benzaldehyde, it would have done the other chemistry, the acid-base chemistry. Remember, a proton, that's the lightest atom we have out there, and proton transfers are some of the fastest reactions that we have, and they will always be faster than, the addition of an electrophile as heavy, for instance, as benzaldehyde. All right, so that's protecting groups.